Hi folks, in this video I'd like to show you the machine I've just designed in Solidworks 3D. What it consists of, I think you can see it quite clearly there. It consists of a plane and chisel sharpening machine, which is foot powered, treadle powered. The entire thing's made out of laser cut flat plate, and no welding is required in the whole setup. So basically we'll start with the two sides. I've got my logo, the shamrock in the middle there. They're 10mm thick plate, these themselves, identical on both sides. Now they're held together with a series of solid steel round bars, one there, two in the midriff, and then the top itself is held together by that solid aluminium plate there, and the whole thing is held together with 10mm 125 metric Allen bolts basically. It works on a pulley system, a pulley crankshaft system, which is all laser cut and tack welded, MIG welded. You see the crankshaft there going round, and that works off a foot treadle at the bottom here. These two bars, and on top of there would be a plate of wood to rest your foot on top of. Again, that's all pinned. Again, no welding needed. In fact, the only welding that is needed, if you wanted to do it that way, you could weld this crank web to the main shaft itself, but I'm going to opt for roll pins, which go right through there and right through there on the little end as well. And then the main conrod is made of, you can either get it made of aluminium, or in this case I'm going to make mine out of wood with two brass bushes in the actual wood itself. You can look around the back there, you can see the actual the conrod and the crank itself there. So that piece there, that would be made out of wood. The bearings for the bottom are just the standard, people call them pillow block bearings or agricultural bearings, with a self-centering shaft in the middle, 1 inch or 25mm shaft in the centre, and they're just held together again with 10mm Allen bolts. The flywheel itself consists of, again, two pieces of 10mm plate. In fact, sorry, 3 pieces. You've got a central piece there in the middle, and then one on either side, and they're bolted together, bolted and threaded together to give it the reciprocating weight. You could just have a plain solid wheel if you wanted to. I've just drawn some hearts and circles in the middle there just for some aesthetics. These two are 3/4 solid steel bars, again threaded and bolted into the onto the end plates, and then the pulley system runs in the centre of the wheel itself, which is just a square section, and that's 10mm deep, is that the middle section there, and you've got 2 plates that come from either side, so like a leather belt fits in off what you would see on the Singer-Saw machines, on the industrial Singer-Saw machines, and it goes round up through this pulley here, and then the second belt goes on this side and goes round the intermediate pulley and then round the main pulley itself and back down again. So you've got a leather belt drive system. In the centre of this solid plate, you've got just 2 standard bearings, 6303s I think they are, onto a 17mm shaft, which this main pulley, the main drive pulley, fits onto as well, and which is pinned, and that rises up through the centre So if I do a sectional view through there, you can see the component parts inside. It gives you a basic view there of the main plate. Another block which holds this block here holds two 6303 bearings, which holds the main shaft through the centre, which goes up through the top, and then the main stone itself fastens onto another plate which is there, which this piece is actually the sharpening stone, and that just sits snugly onto the top of another drive plate there, which is pinned to this main shaft. So it's fairly simple construction, and the green vessel there is to trap the water and drain the water back down into a drain if you wanted to, and a drip feed from a water drip feed tank from the top. So it's looks complicated, but it's not. These pulleys, all these pulleys here, can either be made out of metal or nylon, and I'm going to use nylon because I can turn it by hand on the woodwork lathe. I don't need a metalwork lathe for it. And then the whole construction itself, at the top here for these retaining plates, as you can see there, they're actually notched into the main side plates. So everything's self-jigging. You don't need to line it up. You just need to build it on a flat surface, on a flat level surface. And then the bearing, there's two bearings there pushed into the steel plate itself to hold that pulley shaft there. So there's not a lot of welding needed, or no welding needed if you so choose. And then the actual jig itself for holding, I'll come out of the sectional view. The actual main platform is two 3/4 inch steel square rods, and the whole thing, the bolts go through the side into the block itself. So that's all self-jigging as well. And then the actual blade holder is you can buy these already made for sharpening planer blades, and all I did with mine was convert the bottom end in there. I put a bush into the bottom there, which slides along this rail, so you can sharpen your blade as it's turning. You just move this left to right by hand, and like I say, you don't have to make this if you don't want to. That would be probably one of the most expensive bits if you're going to make it, but it's something that I've fancied making for a couple of years now, and I'm slowly but surely trying to find the second-hand pieces of metal, new metal where I would need it, to get the project on the go. So I'd like to be able to fund it through Patreon, but I haven't actually joined Patreon yet, and I could actually do an apprenticeship if anybody wanted to come and learn or download the files, the 3D files, for having it all laser cut. Laser cut's the way to go. There's no this the cheapest option, because the whole thing there could be cut out in less than an hour on a laser. Well, in probably just a few minutes actually, if it's a decent laser. And they cut the whole lot out, all the holes where all the bolts go, everything all done. So there's no work to do. All you have to do is really basically assemble it. So I'll give you another look at the top end there. That's the planer blade actually in the jig, which is resting against this stone. And like I say, it moves backwards and forwards across the stone to evenly sharpen without wearing out the stones. Now the stone is a standard, you can get the Tormek grinders. That stone there is a stone out of a Tormek grinder, and instead of using the edge of the stone, which you would on a Tormek that way up, you use it on the flat. And there's lots and lots of different stones you can actually adapt this to. you just mean altering the central hole there to act as a drive. So that's basically it. It's not that complicated. Like I say, this bearing block that holds the bearings, that's going to have to be turned on a lathe, and then interference fit into this plate here, or you could actually put Allen keys through this block from underneath. You could put some Allen keys on that edge there and screw that to that plate if you wanted to. Lots of different ways you could do it, but there isn't another one on the market, I don't think, like this, which is treadle powered. So you could, and the whole thing, I think it's about a metre high altogether, and you could actually lift this. You know, a reasonably fit person could lift this into the boot of the car and take it anywhere for sharpening, because anybody knows that if your tools aren't sharp, it makes you work that much harder. Like I say, this rod which the sharpening block slides along, that's again square material, and it's got two spigots turned at the bottom there. You can see that just literally fit in a slide fit. So there's, you know, as long as it's a good slide fit and keeps it firm and square, no need for screws, etc., etc. So it's a foolproof design. It took me a while to work it all out and get these pulley systems aligned, but all those pulleys there are all exactly the same diameter. It's just where you position them on that shaft. As you can see there, there's a roll pin hole there for actually keeping it in situ on that shaft itself, and there's the two bearings, the two bearing housings which push in from either side and go through the actual plate itself there. So simple way of doing it, and an effective machine to use without electricity. It works out at about 25:1 ratio, so the stone's not going too fast. Obviously, the faster you the treadle, the faster the stone will go, but you don't want the stone to go too fast. You want it to go slow, so as it doesn't heat up, you know, the very edge of the planer blade itself. So I think that's about covered everything. As you can see, everything fits together there. The main rail, the side, and the main block there. I mean, you could make that block out of wood if you wanted to, but a piece of aluminium's not that expensive, and it consists of 2, 4, 6, 8 10mm Allen bolts to hold the whole thing together, and then you've got 10mm Allen bolts through the bearings there themselves as well. So when I eventually get round to doing it, I will keep everybody posted. And that's my homemade treadle powered horizontal sharpening machine. So thank you again for watching. Bye for now.